Hello everybody and welcome to Bite-Sized Chemistry, and we are today going to be looking at oxidation reduction. So the main questions here that come up is you're asked to define either oxidation reduction in respect to either electron transfer or oxidation number. You're also asked to determine the oxidation number to be able to identify the oxidizing reducing agents and to balance chemical equations. Now, you cannot identify any oxidizing or reducing agents or be able to balance equations if you cannot determine the oxidation number. So you really do need to know that part of it. When this comes up in exams, it usually comes up either the question 4, which means it's only going to be worth 6 to 7 marks if it does, or it can come up in the question 10 or 11, and if it does so, it'll be worth 25 marks. This can vary year to year. So let's get started. In 2020, it came up as a 25 mark question. You're asked a standard enough questions, and generally you're going to be asked at the very beginning of these questions to be able to define oxidation in respect to electron transfer, change in oxidation number. Now, as soon as electron transfer comes up, you should be thinking oil rig. So oxidation is loss of electrons. Okay, reduction is gain of electrons. So you write down oxidation is loss of electrons for electron transfer. And then for the change in oxidation number is the increase in oxidation number. So that's fine. There are just two definitions, and you can see there they could be worth, well, it doesn't say here how much they're worth, but they're usually worth around 6 marks or more. Underneath that, you're given a bit of text there about the Nobel Prize for Chemistry and using a battery, and you're to assign oxidation numbers for the equation here. Now, first things first, you write out the equation like I have here. Next thing you want to do is, and make sure you do it nice and big, because on top of each of the letters there, each of the elements, I'm going to put in the oxidation numbers. Okay, so starting from left to right, okay, lithium is in group 1, and generally if they're in group 1, they have a +1 oxidation state. So I do a +1 here. Now, there are 6 here, so I do a 6 brackets, okay, and it has to be a negative number, because if you think about it, the overall charge of the element is neutral, so therefore it has to equal to 0. Okay, that's just the rules of the oxidation numbers. Now, this is slightly unusual, in which you're not given a full number. Okay, you're going to be given a decimal point, and generally that's not the case. Okay, you're going to, 9 times out of 10, you will be getting full numbers, but in this case that wasn't. So I just do 1 divided by 6, so that's going to be 0.166. Unusual. Okay, let's move on. Cobalt, well, we don't know what, that's not assigned to any particular group that we've dealt with in terms of the rules. So let's just go to oxygen. So we have 2 here, so we have two brackets, and oxygen is usually -2, unless it's in a metal hydride or not metal hydride, unless it's a peroxide. So 2 times -2 is -4, so therefore cobalt has to be +4. And I always put a plus sign in as well. Carbon over here has to be 0 because it's on its own. Okay, even though there's 6 of them, it doesn't matter, it's still on its own, considered to be on its own. Oxygen over here, we have 2 brackets -2, so that's -4 in total. Over here we have our lithium, which is again +1. It's in group 1. Generally group 1 are +1. And we must figure out what cobalt is. So we have -4, we have +1. So therefore you can argue there that cobalt is going to be +3. I just rub out this. Okay, and that will make sure that it's balanced. Now you're asked from the question there to assign oxidation numbers and determine which one is being reduced. So let's have a look at it. You can see I already half gave an answer there. Cobalt. So let's look at carbon. Lithium doesn't change, so let's look at carbon. Carbon goes from minus to a positive, so therefore it's been oxidized. Increase in oxidation number. Whereas cobalt is going from +4 to +3. So therefore it's been reduced. Okay, so in this case here, which element is being reduced? Cobalt is being reduced. Now you should always, for any of these, get one to be oxidized and the one to be reduced. That's always the case, no matter what. Underneath it, identify which element acts as the oxidizing agent. The oxidizing agent is always itself reduced. Like for instance, potassium permanganate when you're doing those experiments. Okay, that's a really good oxidizing agent, and therefore it is always itself being reduced. So in this case here, cobalt is also going to be the oxidizing agent because it is being reduced. And carbon is going to be the reducing agent because it's being oxidized. You have to just learn that off. Now, Underneath it was using oxidation numbers or otherwise balance the following redox reaction that occurs. Now, this was slightly unusual. Okay, again, this question here wasn't so straightforward as previous years, in which you were given two PBs, two leads on either side. Generally, you're only given one. Okay, so that helped to confuse matters there. So I write out the equation here, and you can see I have it filled in to too much at the moment. And now what I'm going to do is I'm going to fill in my large numbers for us. Now, generally, I would balance this using oxidation numbers, but because you're given two leads there, okay, I find it's just a little bit trickier to balance. Okay, so I don't bother using oxidation numbers for this. I just go ahead and balance this as normal. Okay, so if you look on the left hand side, we have two PBs, and on the right hand side we have one. So I put 2 here. Okay, you don't have to do a different color. I'm just putting it there to indicate that there is 2. On the left hand side we have 2 oxygens, and on the right hand side we have 1. So I put a 2 here. That's grand. On the right hand side, on the left hand side we have 1 hydrogen, 1 H plus ion, hydrogen ion, and on the right hand side we have 4. So therefore I just put a 4 over here. That was fairly straightforward, really, in terms of balancing this. Normally, I would strongly recommend though that you do it that way rather than trying to do it by oxidation numbers. It was easier. The last one there, VI. Why is the recycling of batteries desirable? Okay, to avoid pollution, particularly for heavy metals. Okay, batteries contain heavy metals, so that's we want to avoid pollution. It's better for the environment. Okay, moving on to 2019. You're asked for the oxidation numbers in the following here. Okay, so SO2 and SO4 2 minus, and we're looking for the oxidation number of sulfur. Okay, so starting off there, we write out our SO2. Okay, perfectly fine. And now we want to write in on top of that in brackets 2 bracket minus 2, because oxygen is minus 2, isn't it? So therefore sulfur has to be plus 4. And I would refer to it down here, sulfur plus 4. Okay, make it easy for the examiner. You don't need to have the plus in it. You could just have a 4 in it if you want. I generally just do the plus in the end. SO4 2 minus. Okay, so we do the exact same principle again. I come over here, I'm going to write in my brackets 4 bracket minus 2. So we get a total of minus 8. Now, we have a minus 2 charge overall, a 2 minus charge here. That must mean that overall oxidation number has to equal that. So therefore, sulfur has to be plus 6. Again, put your brackets in. Okay, oxygen is minus 2 and sulfur is plus 6. It just so happens that there are, how many oxygens? 4 oxygens there. So sulfur plus 6. Okay, that's it. Nothing too complicated there. Moving on, 2018. Same principle again. You're to use oxidation numbers to show whether chlorine was oxidized or reduced. So I write out the full equation here. So that's your NaOCl plus H2O2. Now, as soon as I see H2O2, a few alarm bells are going off there, simply because you have a peroxide. And also, as soon as you see chlorine, some alarm bells should be going off there too, because chlorine is is a halogen, and when you see the halogens, you must refer to the oxidation or to the electronegativity values. Okay, so you are going to need your periodic table for this. In particular, you're going to need the electrochemistry part of it, electronegativity part of it. I'm trying to say there. Okay, so getting started. Let's just do the easy ones that we know for definite. Okay, like for instance, O2 over here has to be 0. So that's grand. H2O. Okay, so we know there's 2 here, bracket 1 plus 1. And therefore we have a minus 2 over here. So that should be okay. Okay. And then the rest of it is involving either chlorines or peroxides. So we have to pay attention to that. Okay. So let's have a look at it. NaOCl at the first one here. You have to go to your log tables there, and it is on around page 70. Look, I can actually tell you exactly what it is now on your log tables for electronegativity. It is on page 81, actually. Sorry, my mistake there. And what you're doing there now is you're looking for the halogen, chlorine, and you're looking for oxygen. Okay. And you have to determine which is going to be the bigger size, okay, in terms of electronegativity. If chlorine is bigger, then that rule takes over. If oxygen is bigger, then that rule takes over. So if you look at electronegativity values, you'll see that oxygen is the bigger electronegativity value. So therefore, oxygen is going to be the -2, as it normally is. Perfectly fine. Okay. Sodium there, okay, is going to be our +1, because the sodium is in group 1 and it usually is a +1. And chlorine therefore has to be a +1. We look at our peroxides, okay, generally oxygen is -2, but in peroxide it's a -1. So it's 2 brackets -1, and we got a 2 brackets +1, which is balanced. And then we look at our NaCl, and again, you're referring to your halogens, and halogens are usually -1 if the electronegativity value is bigger, which chlorine is, so that's going to be -1. And finally, sodium here is going to be +1. Okay, so we're looking for the element that to show where the chlorine was oxidized or reduced. So we didn't even need to deal with peroxide so much, but it's a good practice to see. So chlorine is going from over here to over here, and you can see it's going from +1 to -1. It is being reduced. Let's stick with reduced there. I can't spell today. So it's being reduced. That's it. Okay. 2017, you're asked to assign the oxidation numbers for OF2 and XeF4. Okay. So starting off with our OF2. Now, as soon as you see a halogen, like I said, girls, you have to, or whoever's listening, I should say, I teach all girls, you have to pay attention to the rules. Okay, F being a halogen, so therefore its rule usually takes over. Okay, usually. So fluorine in this case here is going to be 2 brackets -1. Okay, it has the large electronegativity value, so that rule takes over. And if it does have large electronegativity value, therefore it's going to be -1. And that rule only applies for the halogens, which is group 7. So therefore, oxygen in this case here has to be +2. I know I'm not using a different color pen for this, but you know what I mean here. So oxygen, okay, is going to be +2. Underneath it, we have our XeF4. Okay, and again, same principle again. You have your 4 over here, bracket, and then you have your -1. So Xe has to be +4. So you're asked for Xeon in this case here. So Xeon is +4. And that's our answer for that. So just be careful with the halogens. As soon as you see them come up, you have to check the electronegativity values. And if it's greater, it's -1. If it's not greater, then the other rule applies. So if it's oxygen there, or if it's something else, that's what you have to look for. Okay, again, this is a 25-mark question now, so this is 2016. Define reduction in terms of electron transfer in change of oxidation number. So in this case here, we have electron transfer reduction is the gain of electrons. So oil rig reduction is gain, and then obviously it's electrons. Oxidation number, it is the decrease in oxidation number. Underneath that, then you're given 2 equations there. This is fairly standard. For the first equation, you are to identify the oxidizing agent, the reducing agent, and then you are to balance either of those equations. So you can do either of those. Okay. So let's get started. So we have our ClO, and we write out our equation. So ClO minus plus S2O3 2 minus. Now, the amount of students that I see taking this down incorrectly is shocking, really, okay? Because if you take this one down incorrectly, you're obviously not going to get the correct answer. Okay, so you're losing your marks straight away here, or losing some of the marks. So SO4 2 minus plus H plus. Okay, so I'm going to do a different color pen for this. In an exam, really, you should only be using blue or black. I just think it helps me to do it. So coming over here, we have chlorine and we have oxygen, so therefore we have to pay attention to those electronegativity values. Okay, and Again, we have oxygen, so which is the greater number? Oxygen is a greater electronegativity value, so that rule takes over, so it's -2, and therefore chlorine has to be +1. The reason is +1 is because you have a negative charge overall. Next one, we have 3 oxygens and sulfur. We have no idea what sulfur is, so it's going to be 3 bracket -2, so that's a total of -6. So therefore we have 2 brackets here. And we find out what sulfur is. Sulfur has to be 2. I'll tell you why, +2. So 2 times +2 obviously is going to be 4, and 4 minus 6 gives us our -2 charge, which you can see there. Okay, that takes practice. Okay, and don't worry if it takes a few attempts. That's perfectly fine. So over here we have -2 brackets +1 brackets. Over here we have -1 because there's a negative charge. Sulfur we don't know, but we know there's 4 oxygens, so that's 4 bracket -2, so it's -8. For the sulfurs, therefore it's going to be +6. And for hydrogen we have +1. Okay, so let's have a look at it. If you notice, the hydrogens and oxygens, they don't change in terms of their numbers, oxidation numbers. So therefore it has to be chlorine that we're looking at. First one. So chlorine is going from a +1 to a -1. So therefore it's been reduced. So I write it down over here. Chlorine, I'll just do a different colour pen. Do I have it written down already? I don't. Okay, is the reducing or is the oxidizing agent. And then I go to the next one there, guys, and it's sulfur. Sulfur is going from +4, or -4, I should say, to +6. Okay. So sulfur, therefore, is going to be is being oxidized, therefore it's reducing agent. Sulfur is a reducing agent. Okay. Next, you're asked to balance either of those 2 equations. Now, you might as well balance the first one because you already have it half done. And I always use the oxidation numbers for balancing these. This is more of a standard question. So the first thing I do there now, guys, is I rewrite everything here. Okay, so I'm just going to copy and paste this. Now, I only rewrite the equation. I don't bother with the actual, the rest of it. So I'm going to rub all the rest of it out there. Okay, all the oxidation numbers and stuff like that. I find that makes it messy. You can use this if you want. It doesn't actually matter, but it makes things easier, I find. Now, whenever I'm balancing these chemical equations, I always ask myself here, what's the story with the oxidation numbers, the oxidizing agents and reducing agents? So let's just see. I'll come over here and I'll write down my chlorine and I'll write down my sulfur. Because they're the 2 there that are being oxidized or reduced, and they're the key to balancing this chemical equation. So chlorine is going from, if you look at it above, it's going from +1 to -1. Okay, and sulfur is going from a +2 to a +6. Grand. Okay, now, first things first, okay, is we have to get a difference between them. So +1 to a -1, the difference is there. It's only the difference now, so you don't need to worry about signs, is a 2. Okay, so 1 to 0 is 1 bunny hop on the number line, and then 0 to -1 is a 2. And then sulfur is a 4, which is fairly obvious. Okay, and this is what I do. I swap them. So wherever I have a sulfur, I'm going to have a 2 in front of it, if there's not one there already. And wherever I have a chlorine, I put a 4 in front of it, if there's not one there already. Okay, so I go back up to my equation here. I'm just going to use red now as well, just to show you where these are coming from. So chlorine, the first one there, I put a 4 in front of it. And on the other chlorine over here, I put a 4 there as well. On the sulfur, there's a 2 there already if you're looking at it. Okay, so I don't do anything with that sulfur. Okay, it must equal to the 2. And on the right hand side, if you look at our sulfur over here, there's only 1 there, so I put a 2 in here. The final step then is just to make sure the rest of the oxygens or hydrogens are balanced. So if we count up the number of oxygens on the left hand side, you're given 4 here oxygens, plus 3 oxygens, plus 1. So we have 8 oxygens in total on the left hand side. So we must have 8 on the right hand side. So if you look at it here, we have 2 by 4 here is 8. So we actually have that balanced. And if we look at the hydrogens, there's 1 here and there's 1 here. So this chemical equation is balanced. And that's it. Let's see. The next one is fairly straightforward as well, okay? And we'll actually do it there now. So to find oxidation in terms of electron transfer, change in oxidation number is fine. Use oxidizing agent numbers to identify the oxidizing agent, the reducing agent, and to balance the chemical equation. So we'll do that one as practice, and we'll be a bit faster with it this time. So we have a CD plus a H plus NO3 minus gives us the CD cadmium 2 plus NO plus H2O. Same principle then, guys. You're going to assign the oxidation number. So this could be 0. This is going to be, put your brackets around us. This is going to be +1 brackets. This is going to be nitrogen. It doesn't really matter what group that's in. We don't know what any rules about it. So therefore it's going to be 3 bracket -2. It's a total of -6. So nitrogen has to be +5. +5. Cadmium is going to be +2. Nitrogen over here is going to be oxygen is going to be -2, so nitrogen has to be +2. And then we have 2 bracket +1 bracket -2. Okay, so if we're balancing this here now, guys, we go from cadmium over here. Cadmium is going from 0 to +2, so it's been oxidized. And nitrogen is going from +5 to +2, so it's being reduced. So we refer to our the oxidizing agent, so part 3. So the oxidizing agent, is that what we asked for the oxidizing agent? We were. Oxidizing agent is always itself being reduced. Okay, so in this case here, our oxidizing agent has to be the nitrogen, the NO3. You can refer to nitrogen sometimes, but it's better to write out the whole thing really, the NO3 minus, okay, is the oxidizing agent. And part IV, the reducing agent obviously has to be, in this case here, has to be the cadmium. Because it's been oxidized, itself has been oxidized. Okay, so we're almost done. We're just going to do it. Last thing now is just to balance this chemical equation. So I write it out again. So CD plus H plus NO3 minus gives us CD2 plus NO plus H2O. Okay, so same principle again. You write down at the bottom here what the oxidizing agents and the reducing agents are. Okay, and again, nitrogen really is the key here for solving the as the oxidizing agent. So I just write down nitrogen and cadmium. And my difference for nitrogen is going from a +5 to a +2. To a +2, so, and cadmium there is 0 to +2. Again, we just get our differences. So in this case here, 5 to 2 is 3, and 0 to 2 there is 2. And we just swap them. So wherever there's a cadmium, it's going to have to equal to a total of 3. And wherever there's a nitrogen, it's going to have to equal to a total of 2. Okay, so I come over here, I write a 3 here in front of my cadmium, and I write a 3 here. For my nitrogen, okay, I have to have a 2, has to equal to a total of 2. Okay, so I put a 2 here, and I put a 2 here. And then the final part now is just to balance the rest of it. So I start with my oxygens, and then I'll do my hydrogens. So on the left hand side, we have 6 oxygens there. On the right hand side, we have 2 here, and we have 1 here, so we have 3 in total. So 4 goes here. So 4 and 2 is 6, that's balanced now. And on the right hand side, we have 8 hydrogens, so therefore on the left hand side, we should also have 8 hydrogens. Okay, everybody, I'm going to leave it at that. That's it for balancing the chemical equations and also defining the oxidation and reduction in terms of either electron transfer or oxidation number. The rules for the oxidation numbers just have to be learned off, and practice makes perfect for these. Like really for the balancing chemical equations, like those, there's loads more we can do, of course, But like once you do 102 and you know how to do 102, you know it. Okay, it's fine. Okay, and it's definitely worth practicing, because if it does come up, it's usually a nice question. 2020 being the exception, of course. Okay, everybody, best of luck with your studies.